Hi class, how are you? I hope you are having a wonderful day so far. Okay, let's get started. I will start with concept number 2-3, data set. You see data set number 3, and you have a 1, 2, 3, 4, 5, 5, 7, 8, 9, and 100. And I want you to calculate the mean, median, and mode. So this is what I found out. The mean is written as x bar, average, mathematical average for the data set. And I have 14.5. So mathematically, mean can be calculated by sigma x over n. So sigma means add all the numbers. Sigma means add all the numbers. This is a sigma. So add all the numbers divided by total n. N is case. So I got 145 divided by 10 equal 14.5. So median is the number right in the middle of the distribution data set. I have 10 numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is n equal 10. So I have 10 cases. The number right in the middle is right here, right here. That is the median. So how do you calculate median? When the middle point is in between two numbers, you need to add two numbers. 5 plus 5 divided by 2 equal 10 over 2 equal 5. So the median is 5. The mode is the number that you can see the most. The number you can see the most. So I see 2 5s right here, 2 5s. So mode is 5. Good. Okay. So let me repeat. Concept number 2-3, you need to know how to calculate mean. You need to find out median and mode, the number that you see the most. Median is the number in the middle of the data distribution. However, here, when you calculate the median, you need to arrange numbers from the smallest to the biggest, or minimum to maximum numbers. So I don't see any random order right here. So you can just calculate the median, the number that is right in the middle of the data set. Okay, so that is the concept number 2-3. Let's move to concept number 2-4. If you have a lot of data, here one assumption is you need to have a big data. Lots of data. Well, it really depends on how big the population size is. Then you can find out distribution. So the first concept of distribution is normal distribution. If you have a lot of data, numbers will be normally distributed. Versus numbers will be abnormally distributed. That is abnormal distribution. Again, we have two different types of distribution as of now. Okay, normal distribution is here. So you can see a beautiful curve. This is also called bell-shaped or normal distribution curve. So now you can see the middle section is really high, and we have a few cases. Those are called outliers. Very few low scores somewhere around here and very high scores, a few cases right here. But in most cases, you can see a lot of people or numbers are right in the middle. That is called normal distribution, also known as bell-shaped or normal distribution curve. For example, we talked about U.S. income. Most people make around 70K. But homeless people, some poor people, they make less than 10K. However, we have super rich people in this society as well. So they make over 100K, or the data can be stretched all the way to the right, all the way to the left, $1 million. Right? So technically, this curve can be stretched all the way to 0. And this right side can be stretched all the way to infinite. Right? So some people make $1 billion. So those are really, really rare case. Rare case. Okay, so let me close this down. And then I'm going to open new distribution. So we are on concept number 2-4, normal distribution. I want you to answer this question. What kind of curve is this called? This is called normal distribution. Normal distribution. So numbers are normally distributed. That has middle section, a lot of cases, and a few cases on either left or right side. That's a normal distribution. Normal distribution. So if you look at concept number 2-4, in your class note, you can see normal distribution. Normal distribution. However, sometimes you will see miniature of distribution from normal distribution. Looks like a normal curve. However, in the middle section is really, really popped out. Right? Sometimes you will see very flat. Very flat. Very flat. However, you will see the middle is always high. According to the central tendency, the middle is always popped up, popped up, popped up. But their shape is relatively different. This one is called leptokurtic. Let me spell out leptokurtic. This one is platykurtic. This one is also known as mesokurtic. Mesokurtic. Okay. So now you can see kurtic. However, you have different prefix. Meso, lepto, platy. Meso means same. So this side and this side, they are absolutely same. So this curve is called normal distribution or bell-shaped or mesokurtic. They are all the same. So bell-shaped. So what is this distribution called? Normal distribution curve or mesokurtic or bell-shaped. They are all the same. However, the next distribution, which is known as leptokurtic. Lepto means slender or very sharp. This distribution looks like a normal distribution, right? A few outliers on the left side and on the right side. However, the middle section is relatively high. This distribution is called leptokurtic. For you to better understand, I will just write down, draw another graph right there. This is a normal distribution. So leptokurtic looks like a normal distribution. However, they are higher than normal distribution in terms of the thickness. Okay, so that is called leptokurtic. The next one is called platykurtic. Platykurtic means flat. The distribution is very flat, okay, or very broad. Okay, so let me repeat. If you have a lot of data, numbers will be distributed beautifully. A few cases on the left, a few cases on the right side. That is called normal distribution. Normal distribution. Or mesokurtic, right side, left side, they are the same. And it's also known as bell-shaped distribution. However, sometimes you will see leptokurtic as well. Kurtic means curve. Curve. So mesokurtic is same curve on the left and right side. This one is a very slender curve or sharp curve, leptokurtic. Platykurtic, very flat curve or broad curve. That is platykurtic. Okay. Next, still we are on concept number 2-4. We will talk about abnormal distribution. So this is a normal distribution or mesokurtic or bell-shaped, right? So if you fold this distribution to the center, half and half, this one should have 50%. Negative side, positive side, or small numbers and big numbers, and a lot of numbers centered in the middle right there. This is called normal distribution or mesokurtic or bell-shaped. They are the same. Okay, remember they are the same. However, abnormal, this is a normal distribution. Sometimes distribution will be stretched out to the right side. Or sometimes you will see distribution will be stretched to the left side. Okay, this is called positively skewness. This is called negatively skewed. Okay. So let's take a look at one example for positive skewed or skewness. A lot of people make right here $70,000. If you collect data on the annual income from Bill Gates or Mike Zuckerberg, Facebook CEO, their numbers will be $10 billion. So this distribution will be stretched all the way to the right side or big numbers, right? In this case, this distribution is skewed out of curve to the right side. Then this is called positively skewed. This one, well, most of you will get 90% of the test. Well, a few cases, perfect score. Some people will get 60 or 50. The test is relatively easy. The mean is 90. However, some of you will get 1, 2, 3 out of 100. These numbers are very, very abnormal. That will change the curve skewed out of the shape negatively, right? So this is called negatively skewed. This one is, let's go back. This one is still normal distribution, normal mesokurtic. Okay, mesokurtic. Again, distribution can be stretched out to the right side. Right side. Hold on, is this the right side? Right side, that is a positively skewed. And in this case, numbers will be distributed to the left side. That is negatively skewed. What about if I ask you to do push-ups in class? Push-ups. What kind of distribution will you see? Okay, normal distribution. We have a normal distribution. We have a leptokurtic. We have a platykurtic. We have positively skewed. And we have negatively skewed. If I collect data on your number of push-ups in class, what kind of distribution will you expect to see? Or it really depends on what data we will get. But if we collect data on push-ups from the population, we will see normal distribution. Most of people will do around 20 push-ups per minute. Some people can do 70, but some of you can do only 2 or 3. That is the normal distribution. However, if we collect data on professional baseball players, then we will see positively skewed. Some people can make $300 million per year. For most rookies of Major League Baseball players, they will make about $1 million. And minor leaguers, and they will make about $500,000 per year. That can be one example, right? That can be one example. If I ask you to count how much money you have in your pocket right now, most of you will have, well, I have a $5, $10, $15, 20, and all of a sudden, one of you will have $100. $100. Then this distribution will be, well, most people have somewhere around $10 to $15. Then all of a sudden, we have $100 right there. So this one can be a good example of positively skewed. Positively skewed. However, if you collect data on how much money you have in your pocket in Hollywood, that will be different. Most people will have about $1,000 in their pocket, at least like $500. That might be normal. But unfortunately, you got data from homeless people on the street in Beverly Hills, you get $1. And distribution will be negatively skewed. So concept number 2-4 has two terms that you need to remember. Kurtosis and skewness. Kurtosis means how high is the distribution? How high is the distribution? Skewness, how numbers are distributed to the right or left, stretched out. If your data is normally distributed, then you will see and get normal distribution, equally distributed, half and half, 50%, 50%, with a relatively good height. That is the kurtosis is how high, how sharp, how flat the distribution is. Skewness, the distribution is shifted either right or left. That is the concept of skewness and kurtosis. I will continue to concept number 2-5 with the next video. Thank you for watching.